Hi everyone, today we're going to present our group assignment regarding on our course KIB 1011 Statics and Mechanics of Materials. The medical device chosen by our group is crutches. So first of all, let me introduce our group members. Our group consists of 4 members, including me myself, Fatiyatun Najwa, and Nur Kamarina, Nurin Batrisha, and lastly Nur Shazwani. So what is crutches? Crutches are medical devices that help to provide support for patients with working disabilities. It is mainly designed to transfer the patient's body's weight to the arms and torso. There are 3 types of crutches, which are axillary crutches, gutter crutches, and elbow crutches. However, in this study, we mainly focus on the axillary crutches. Axillary crutches or underarm crutches are best in short-term as well as immediate use, as it is easy to be used compared to the other types of crutches. It is also made from aluminum alloy, which provides stability and durability. The cases of crutches fracturing are very rare, as a lot of improvements in design as well as the material used to make the best crutches throughout the year. However, there are still problems that arise when crutches can cause injury, such as crutch paralysis due to improper use of crutches. So, in this study, we will be discussing the ways to overcome these problems as well as measuring the dimensions of crutches related to our course.
Now, I will continue with the problems that can happen when using crutches. First, it can cause crutch palsy. Crutch palsy is a radial nerve palsy that occurs when improper use of crutches and too much pressure on the axillary padding due to the weight of the user. Second problem is aneurysm. Aneurysm is a bulge in the blood vessel that caused by friction between axilla part and the pad. Lastly, damage at the base or the tip of the crutches. The damage occurs when there is too much pressure exerted on it. These are the objectives that we want to achieve in our video. First, to present the free body diagrams of crutches and use it to determine forces and moments applied to a body using equilibrium equations and to calculate reaction in mechanical problems of crutches. Second, to solve problems involving crutch body under the action of axial, bending and torsional load. Third, to solve problems due to compound load based on moment and inertia analysis. Fourth, to calculate and evaluate stress and deformation of crutches. And the last one is to solve the problem of real-life cases involving crutches. This is the free body diagram of a person holding a crutch. As we can see in the diagram, there are several forces exerted at the crutch, which is friction force F, normal force N, and weight of the patient W. There is also theta or angle between the crutches and the ground. Basically, friction force is the force that resists motion when the surface of one object comes in contact with the surface of another, and normal force is the force that a surface employs on any other body.
To calculate the stress due to bending, we use the formula stress equals to negative my over I, whereby y is the vertical distance from point of stress to centroid. For the centroid, we have located it to be at 0.971 meter above the x-axis. And for this calculation, we assume the moment as x Newton meter. So after calculating, we have found out the answer, which is negative 6.204 x Pascal. For the torsion part, we calculated the maximum shearing stress using formula tau max equals to Tc over J. For our crutch, we use the base part where the radius is 0.02 meter. And we calculated the polar moment of inertia, J, using 1 over 2 pi c to the power of 4. Assuming torque is y Newton meter, our tau max is equal to 1 over pi 2.5 times 10 power 5 y Pascal.
Moving on to the moments of inertia. To calculate moments of inertia, firstly, we divide the crutches into some sections to ease our calculation. Then, we use the table where we find the A and Y bar to find the first moment for all the sections. Then, we use this formula where we divide the total first moment by the total of area, where we got 0.98 meter as the centroid of our crutches. Then, we use parallel axis theorem where I equals to I bar plus AD squared. For this study, we use the parallel axis theorem for rectangle and semi-ellipse. Then, we total up the moment of inertia for each section, then where we got 216.64 times 10 with the power of -3 as our total moment of inertia.
Next is deformation. Deformation is a change in shape due to an applied force. This can be a result of tensile or pulling forces, compressive or pushing forces, shear, bending or torsion. Deformation is often described in terms of strain. To calculate deformation, first we need to find the reaction at A by adding all forces at y-axis and equal it to 0. Then we can calculate RA. On the right side is the formula of deformation. Delta equal to P times L over AE. Reaction at A is RA. Delta stands for deformation. P is force, either tension or compression. L is length. A is cross-sectional area and E is modulus of elasticity. After that, we need to separate it into different components. For crutch, we separate it into 3 parts. Since we want to find the deformation of the whole crutches, we need to calculate one by one deformation or delta of every part and after that we total it. This is how we find delta. First, we need to calculate pressure of every part of crutches at y-axis. After that, find the length of every part for each delta. Then, calculate the area. For delta AB and BC, the radius of cross-sectional area is 0.01 meter and the radius for delta CD is 0.015 meter. To calculate cross-sectional area, we use formula pi r square since they are cylinder. After that, we use the formula of deformation that I have mentioned before to calculate delta for every part or component and we total it.
For the next part, factors that affect failure. Basically, failure means the disintegration of a material that leads to separation of a particular object. In our case, the separation or breaking of the crutches due to disintegration of aluminium alloy. As you can see in the stress-strain diagram on the right, aluminium alloy can only hold a maximum stress of up to around 340 to 350 megapascal, which is also known as the rupture point. After that, the material will undergo deformation or will break. Apart from excessive load, other factors that can affect failure is unsuitable material, wrong manufacturing procedures, inadequate design, as well as change in chemical composition.
To prevent conditions such as sore armpits, shoulder pain, rib pain, and hand pain, the crutches must be used correctly. Firstly, make sure the tops of your crutches have a short distance, about 2.5 to 5 centimeters, just below your armpits when standing straight. Secondly, for hand pain, make sure the hand grips are parallel to your pelvic bones and make sure that the padding is not worn out. The hand grip and crutch pad can be covered using cloth. It can effectively reduce the pain from crutch pad and hand grip. Other than that, hand grips have always been adjustable in the up, down, forward, and back positioning depending on user's needs. It can effectively reduce the strain on the user's wrist and improve stability. All the problems mentioned before are caused by improper crutches use. To overcome these problems, correct ways of using crutches must be applied. Here are the correct steps while walking using crutches. In diagram 1, put the crutches ahead and to the sides of your feet for the best balance. Next, move both crutches forward at the same time. In diagram 3, move the injured leg forward between the crutches. Gently squeeze each crutch into your ribs. Put weight through your hands and keep your elbows straight. Move your uninjured leg ahead of the crutches or to between the crutches for better balance. Repeat these steps to keep walking. Remember not to lean on the crutch top. Aluminium 6061 is used widely in the making of the crutches. Aluminium is light and strong at the same time. The average weight of aluminium only ranges about 1 to 2 kg. Since they are light, They are more suitable to be used in a long period of time, so it would not cause so much exhaustion. Next, aluminum crutches are more comfortable. Most aluminum crutches have soft pads for hand grips and crutch pad. Besides that, aluminum crutches are cheaper than other materials. There are many factors that affect aluminum crutches prices. Hence, they can range about 50 ringgit to 90 ringgit. Lastly, the most important factor is aluminum is extremely durable. Aluminum is one of the most long-lasting materials. It can resist heavier weight than wood and most plastic crutches. Aluminum crutches have a weight capacity ranging from 80 kg to 140 kg so that they fulfill the needs of most users. Here, we would like to suggest a good way to reduce pain in hand grips and armpits. The patient can choose to use spring crutches. These crutches include a certain mechanism that contracts or expands under loads. Hence, they change the way the forces are transferred to the body during a dynamical gait cycle. It was proved that they lower down the initial peak load by 25% and the average amplitude of the initial force by 20%. Hence, the shock absorbing feature boosts pleasantness by lowering the stress and pain. An experiment conducted shows that the proposed method is effective, efficient, and insightful. The experimental results prove that spring-loaded crutches provide a successful propulsion mechanism which has not been found yet in other experiments of crutches. In addition to the shock-absorbing feature, the propulsion mechanism gives the spring-loaded crutches a further advantage over standard crutches. In conclusion, disabled people can choose spring crutches compared to old traditional crutches.
In conclusion, this assignment has allowed us to demonstrate the learning outcomes as well as perform equilibrium-based analysis and calculations. On top of that, we have managed to identify several factors that can cause failure of a material and the maximum force for aluminum alloy before it ruptures. In the case of crutches, we have discovered a few problems. First one is harsh forces on the body. Second is the rubbing between axillary padding and the axilla. And the third one is damage of the tip of the crutches. Hence, we have come up for solutions for these problems, which is first by using the crutches in a correct way and manufacturing the crutches using suitable material, as well as introducing spring crutches instead of traditional crutches.